Now is the right moment. The first signs of life in space have been discovered. The James Webb Space Telescope has uncovered a planet that is even more favorable for life than Earth. Biomarkers detected in the exoplanet K218b's atmosphere suggest that an exceptional ocean covers this world. However, how can we currently determine if there is intelligent life there? If hints are provided by James Webb and others, will we ever be able to reach K218b? The exoplanet hunt is underway. James Webb, the next star telescope in the night sky, is intended to investigate exoplanets more closely in addition to looking for signs of life on other worlds. Only since 1995 have we been able to find other planets in space. Our telescopes were just not sensitive enough to detect these planets since they are so small. Take a look at this photograph of Earth obtained by Voyager 1 in the early 1990s. Merely a dot. Remaining inside the solar system, Voyager 1 was only 6 billion kilometers away from Earth. The distance to the closest stars in the Alpha Centauri system is at least 132 trillion kilometers. That should help you understand how small planets are in relation to the size of the universe. It has always been like detective work to find them. For this, scientists employ a mechanism wherein the minuscule planets show up when they pass in front of their stars. The transit method is the name given to this kind of planetary finding. Another technique uses the minuscule gravitational shifts that planets induce in the motions of their stars to identify the presence of planets in a solar system. Although there are occasional issues with both approaches, we have successfully detected over 5,000 exoplanets. The next obstacle is that criteria like the presence of water or atmosphere have not yet been determined, which makes it difficult to establish whether any of them are similar worlds to our own. All we could infer was that they were either less dense gas giants or heavier, more massive rocky planets. Since James Webb has been in operation, this has altered because this super telescope can analyze the light reflections of a planet to identify exactly whether water and other biomarkers are present. You can only imagine how happy James Webb was to discover carbon dioxide and methane in the atmosphere of K218b, the first indications of life on an exoplanet. Equipped with some of the most sophisticated instruments ever sent into space, the James Webb Space Telescope is a real masterpiece of contemporary astronomy. The JWST has the unique capacity to detect and characterize exoplanets. The abundance of data and precision measurements go far beyond the greatest aspirations of scientists. The near-infrared camera, often known as NIRCam, is the most advanced piece of equipment. It was created specifically for near-infrared studies. The telescope's eye is essential for locating exoplanets circling stars because it can detect even the smallest light signals from stars in far-off galaxies. The near-infrared spectrograph, NIRSpec, breaks down the light from stars and planets into its constituent hues. We can infer information about the chemical makeup of exoplanets and their atmospheres from this spectrum investigation. James Webb is able to detect and evaluate the unique light signatures of each element and gas, even across very long distances. We may now see into the atmospheres of far-off worlds and discover their secrets because of this technological marvel. The mid-infrared instrument, MIRI, significantly enhances the capabilities by offering data on light wavelength ranges that are invisible to the human eye. MIRI is able to measure the temperatures of exoplanets and maybe even comprehend meteorological processes on these worlds. It can also detect the thermal radiation of cooler objects, such as newly created stars or dusty disks surrounding young stars. Let's now examine the unexpected information James Webb discovered regarding K218b. Carbonaceous chemicals, such as carbon dioxide and methane, are clearly present on the globe, according to data analysis. According to biologists, carbon is an essential component of life and the building block of all known earthly life forms. Therefore, the presence of molecules containing carbon in a planet or moon's atmosphere may be a sign of biological activity. Methane is a monoatomic compound made up of 4 hydrogen atoms and 1 carbon atom. Methane is mostly created by biological processes on Earth, like digestion and decomposition. Methane is a significant indicator of potential biological activity on a planet, even though it can also be created by some geological processes. Everybody releases carbon dioxide. Although it's also produced in large quantities in industry, it might be another biomarker for cellular respiration on this planet. CO2 alone is not necessarily evidence of life. It can also be emitted in vast quantities by non-biological processes such as volcanism. However, a deeper examination of K218b allows us to rapidly rule out volcanism as the source. The proportion of carbon dioxide to other atmospheric gases is important in the hunt for life. The likelihood that life is present there rises when multiple biomarkers coexist. Rich life on ocean planets. Picture a planet that is encircled by a single, enormous ocean that is around 2.6 times larger than our planet. These are the ocean worlds, which intrigue scientists as a whole new class of planets. In technical terms, ocean worlds are referred to as sub-Neptunian planets. On K218b, James Webb found a hydrogen-rich atmosphere and a lot of water. This implies that there may be life on this planet in addition to a sizable ocean. The exoplanet, which has 8.6 times Earth's mass, is 120 light-years from Earth and orbits the cold dwarf star K218 in the habitable zone. Between Earth and Neptune in size, K218b is thought to have a water ocean beneath a hydrogen-rich atmosphere based on the abundance of methane and carbon dioxide and the lack of ammonia. Dimethyl sulfide, or DMS for short, is a chemical that James Webb discovered to be yet another intriguing clue. On Earth, DMS is only created by life. Phytoplankton found in maritime areas provides the majority of the DMS found in Earth's atmosphere. Future Webb observations should validate these findings once again, at which point we will most likely be able to conclude with high confidence that biological life exists on K218b. Simple life forms like plankton, algae, and bacteria may be present, but more complex life forms like fish or aquatic mammals may also exist. Not to mention, we should never rule out the idea that there may be unimaginable life forms on other planets. Higher life forms that may have adapted to life in water may exist even on a planet fully submerged in water. It is yet unknown whether K218b has land masses. It is challenging to make a determination at a distance. The fascinating thing about this, though, is that artificial light emissions, such those from other planets' cities, should be detectable by James Webb's MIRI device. That's a very exciting development that will significantly progress our search for extraterrestrial life. K218b was not discovered by James Webb. Hubble Space Telescope observations provided the first information about this exoplanet's atmosphere. The promise of this data made researchers eager to use the new telescope to examine this world once more, and their efforts were rewarded. The analyses surrounding K218b are intriguing and may represent our first finding of extraterrestrial life. This is a sensation since, up until now, our nearly century-long hunt for extraterrestrial life has been fruitless. Nowhere in our solar system have living forms been detected. The only places left to look for them are the far-off icy moons orbiting Jupiter and Saturn. Scientists believe that ocean planets may be real superworlds and the cradles of complex life. Mammals and land masses did not arise until much later. Life on Earth also started in water. It's possible that sophisticated life forms that could only exist in water would have evolved on Earth if it had continued to be a water planet. Exoplanets, which are tiny, rocky planets similar to Earth, have historically been the focus of the hunt for extraterrestrial life. Though not all scientists share this view, the larger ocean worlds are now thought to be the true superworlds in the universe. They also speculate that the oceans on these planets may be too high to support life or be liquid. In this scenario, the ocean worlds would resemble enormous steam rooms. However, we now know that life is feasible even in Yellowstone Park, thanks to living forms found in hot, poisonous thermal springs. A mission to K218b. Of course, the intriguing question of whether or not we will ever be able to determine whether the exoplanet K218b is inhabited remains. We would obviously want to get in touch with any sentient life that we might uncover in space. K218b is located approximately 124 light-years from Earth. This distance still poses a significant obstacle to our ability to travel to space. Our probes currently require years to travel several million or billion kilometers to reach their destinations. It is not feasible to think that we could realistically reach a planet 124 light-years distant, or even one that is only 4 light-years away, with a probe or spaceship. In a few millennia, our Voyager probes, launched in the 1970s, will arrive at the closest star systems. We would need to get creative if we were hoping to communicate with a species that existed somewhere in the universe. Proxima Centauri, our nearby star system, may have worlds similar to Earth, which is why space nerd Yuri Milner designed nanospace ships that can travel at nearly the speed of light. In a few years, these tiny probes with cameras are supposed to travel several trillion kilometers and take pictures of worlds that might support life. Our scientists would most likely come up with entirely new concepts if we were to discover a civilization in space. In the end, it is precisely these objectives that motivate our spirit of inquiry and creativity. Reaching worlds like K218b would be a cinch if we could travel through space-time by folding space-time and had warp drive in the future. However, as of right now, our space shuttles continue to accelerate using fuels and propellants inside the confines of Newtonian physics. The distance to K218b would take 1,240 years, even if we could construct a spacecraft that traveled at 10% the speed of light. The distance between Earth and this exoplanet would take 124 years to travel across, even for a radio signal traveling at the speed of light. If a response were to come, it would take an additional 124 years.